What's happening?
It's about 10 o'clock on Saturday evening here. We're observing our first stars of the night. Started about an hour ago. Things are going all right so far. So we are observing for the Gala Survey, which is an acronym for the Galactic Archaeology with Hermes. Hermes is itself an acronym, but let's not worry about that. Things get complex real fast. It's a survey that's aiming to measure spectra of about 1 million stars in the southern sky, to look at their chemical abundances, what elements they have in their atmospheres, and how that changes as a function of age, to understand how the galaxy formed.
Wow, that sounds very cool. So what are you actually observing in these stars tonight?
Yeah, so over tonight we'll observe about 1,500 stars, not sequentially, there's not that many minutes in the night, but we observe about 300 stars at a time, and we'll observe 5 fields. Looking at 29 different elements in their spectra. And so we won't say anything tonight about what's in their spectra, but we'll get data that look kind of like this, if you can see on the camera here. And so each row is a different star, and you'll see little notches cut out here and here. This is wavelength along the x-axis. And each notch is an absorption line from the spectrum of the star, that something is in its atmosphere blocking light escaping, and based off of the fingerprint of what the relative sizes and strengths of those notches and where they are, we can tell what's in its atmosphere. Tonight we're looking at about 30 elements for this program.
So so obviously by field you mean a section of the sky.
Yes.
So how do you pick which sections of the sky to look at?
Yeah, so one of the fun things about this survey is that we're doing as much of the sky as we can. The only thing we care about is a certain brightness range. So stars fainter than 12th magnitude and brighter than 14th. And we're
What does that mean?
Perfect.
As in, like, what do we think? Like, is 12th magnitude as bright as the moon, or can you see it with the naked eye? What is 12th magnitude?
So the stars that you can see, the brightest stars in the sky, and the bright planets, so Mars and Jupiter, are about 0th magnitude. The magnitude scale is backwards, like most things in astronomy. And larger numbers are then fainter stars. So the faintest stars you can see with the naked eye is about 6th magnitude in a really dark site. In Sydney proper, we're talking 2nd or 3rd magnitude. But you go out into far west across the mountains, you can get down to about 6th magnitude. With small binoculars, maybe 8th or 9th magnitude. And here, so 12 is then 100 times fainter than that, and 14 is another 6 times fainter than that. So these are faint stars compared to what you might think with your eye, but they're still pretty bright relative to the galaxy as a whole. These are stars on our side of the galaxy. Some of them might be 500 or so light years away, out to about 2,000 or 3,000 light years away. That's relatively speaking, the galaxy we're 25,000 light years from the center of the galaxy, and so they're all in our spiral arm.
Let's do it. Okay, Ben. So here we are in the remote observing room. What is going on? I can see we've got a screen here that is connected to some other remote location. So can you explain to us what's going on?
Yeah, so we're using a very fancy technological thing you might not have heard of before. It's called Zoom.
Wow.
Yeah, and we are connected to the remote observing room. We are in the remote observing room. We're connected to the physical observing room up in Coonabarabran. And so the telescope is directly above this room. And if we were there in person, we would be sitting at those monitors right now, getting ready to start. But we're here doing it remotely, and so we're waiting for some staff at the telescope to give us the all clear that we can start taking afternoon calibrations.
So is that the sole purpose of someone sitting on the other end, is that we need them to tell us that it's all good to go?
So they do all of the things that we can't do there in person. They check out the instrument and make sure that it's physically ready for people to use it. They make sure the telescope is in good operating condition. They make sure the lights are off before we start taking data. So that's all the things that we can't do here from UNSW, someone is there to help out with.
So what sort of things usually go wrong with telescopes like these?
Yeah, lots of things could happen. It's a very finicky instrument that we're using tonight. It has a little robot that's used to position a few hundred different fibers on the instrument to tell it what stars we're looking at. It's great that we don't have to do that by hand, but the robot's a little finicky sometimes, and so that can throw some errors, or we can have atmospheric problems, meaning there can be rain or fog or things like that, or we could just have software problems. That something about the way that the telescope is communicating with the computer could fail, and we need someone to go turn it off and turn it on again.
So how common are these things occurring? Do they happen all the time, or?
Yeah, this is an instrument that is, the telescope is more than 50 years old. It works really well sometimes, and other times it gets into moods where there are just little gremlins in the instrumentation. And so it's often that several little things will go wrong, hopefully nothing that causes us to lose any observing time or make us end the night early, but it's not uncommon to have 5 to 10 minutes of turning something off and on again during the night.
So when you say it happens fairly regularly, do you mean like every observing night? Or are we talking about once a week, once a month? How often is often?
Not quite every night, but probably every other night there's some minor thing that might happen that's worth checking out. And also we want to be very careful, right? These are instruments that cost millions of dollars. We don't want to accidentally do anything wrong. So people are very careful. If there's any, not even red flags, but yellow flags, we'll stop and check it out and make sure that everything's okay before we push on.
Okay. I got one.
Yeah.
So what are the next steps for us right now? It's almost 6:30. What are we waiting for now? What's going to happen now?
Great. So we are doing two things right now. The first is that we're configuring the first plate using that robot that positions all the fibers to know, which stars on this field we're actually going to get spectra for. So that's being positioned right now. This is a GUI that shows what the robot is doing. So this plate is about 1 meter in diameter, and so you can see all the fibers being moved as the field gets set up. And the second thing we're doing is taking images that are called bias frames that just measure the 0 point of the telescope. Your phone does the same thing, even though it doesn't tell you about it when it takes an image. So it's a very short, effectively 0-second exposure just to see what the 0 point is on the detector and how much noise there is. And so there are several frames that look like this. We take about 20 of them at the start of the night and use that to calibrate when we turn the data from the raw frames we saw last night into something usable, some real spectra, which is a process we call reducing the data. Removing the bias is the first step for that.
So how long does this process take?
So this takes about half an hour. We take 20 bias frames. They're each 0-second exposures, but it takes about 1 minute to read out the detector. We do it very carefully because we want to get as precise of data as we can. So your phone reads out a detector over a couple milliseconds because it doesn't care about as much noise as we do. We want to keep things at the part per million level if we can. And so each one takes about 1 minute. We do it 20 times, so it's a little over 20 minutes. The fiber positioner takes between 30 and 45 minutes, and we'll do that twice at the start of the night because there's two plates. We always have one that we can set up while the other is exposing. So we'll set up both at the start of the night. The whole process, we started here about 5 o'clock tonight, and it's now almost 6:30, and we've got about 10 minutes to go and set up. So it took about an hour and a half. And then after that, we'll wait till sunset, which is 90 minutes from now. And then, weather permitting, we'll open up and start getting on-sky calibrations, focusing the telescope, and getting ready to go.
Okay, good luck.
Yeah, we'll see you soon.
Sounds good. Sweet, thanks for that.
Easy.